Let us discuss few numericals related to the Coulomb's law. Normally some questions like this will be asked in the exam. Now there are three charges, 1 microcoulomb, 1 microcoulomb and 2 microcoulomb, kept at the three corners of an equilateral triangle whose length of the side is 10 centimeter. The question is, what is the force experienced by charge at C? How to find the force experienced by charge at C? Now see, the charge at C will be experiencing a repulsive force from A in this particular direction because both are of positive nature, so repelling force. Let me write it as Fc due to A. That is the force on the charge kept at C due to A. Similarly, the charge at C will be experiencing a force in that direction because, let me write it as Fcb, force on charge due to charge kept at B. So these are the two forces which are acting and you have to find its resultant. So let me write the equation for Fcb, 1 by 4 pi epsilon 0 1 into 10 raised to minus 6 microcoulomb. The other one is 2 into 10 raised to minus 6 divided by the distance is 10 centimeter. You have to convert it into meters. So 10 into 10 raised to minus 2 the whole square. So you, instead of 1 by 4 pi epsilon 0, when you substitute the value of epsilon 0 in this equation, 1 by 4 pi, so you will get it as 9 into 10 raised to 9. So directly you can substitute 9 into 10 raised to 9 multiplied by 2 into 10 raised to minus 12, because the powers will always get added up, divided by 100 times 10 raised to minus 4. So it will be 18 into 10 raised to 9 into 10 raised to minus 12 into 10 raised to plus 2. So you have, because 100 10 raised to minus 4, so 2 zeros will be cancelled. So it will be 10 raised to minus 2, it will go to the numerator as 10 raised to plus 2. So it will be 18 times 10 raised to 9 times 10 raised to minus 10. So you will have 1.8, so 9 and minus 10, so it will be minus 1. So 18 times 10 raised to minus 1, it will become 1.8 Newton. So this is the force on C due to B. Similarly, force on C due to A, magnitude is same, 9 into 1 by 4 pi epsilon 0, here also 1 into 10 raised to minus 6, 2 into 10 raised to minus 6, the distance is same, so you will get the same magnitude, 1.8 times 8 Newton. Now you got the two forces. Now how to find the resultant? Here you have to apply the parallelogram law of vectors. The forces, so P and Q, the angle is theta, then you will find the resultant as the diagonal, where R is equal to root of P squared plus Q squared plus 2PQ cos theta. So here also you can substitute R equals P's values root of 1.8 the whole squared plus 1.8 the whole squared, P squared plus Q squared plus 2PQ, 2 times 1.8 times 1.8, and cos 60. Here theta is 60 because it is an equilateral triangle. If this is 60, this will be also 60. So 2 times 1.8 times 1.8 times 1 by 2. So here it is 1 by 2. So you have root of 1.8 squared plus 1.8 squared plus 2 into, so this 2 will get cancelled and you will get R value equal to, when you use the calculator, you will get the R value equal to 3.12 Newton. So if you understood how to solve this sort of questions, you have to find the individual forces. Then if the angle is given, you have to use the parallelogram law of vectors to find the resultant force. Now another question of not similar nature, some tricky questions like this. You have got two charges, 4Q and minus 2Q, which are kept at some distance and exerts a force of F between them. Since the two are of the opposite nature, obviously the force will be of the repulsive nature. So the repulsive force between 4Q and minus 2Q is F. we are not concerned about the magnitude. The question is, when you touch these two charges, make them in contact and again place them at the same distance, what is the new force? See, when you touch these two charges, so 4q and 2q minus 2q when brought in contact, then the net charges on each will be equal to the average of both. Like 4q plus minus 2q, it will become 2q by 2. So you will have q on each, q on each. So any question something like in contact, obviously when you bring it to contact with a body, here you are making them in contact. So 4q plus minus 2q. Sometimes the question will be like this: you are bringing a neutral body and bringing some question will be like this: 4q and minus 2q is there. You are bringing two bodies. Let the bodies be p and q, and you bring them in contact. 4q in contact with p, minus 2q in contact with q. So when the bodies are brought in contact, then the charges will be, since p is having no charge, so 0. So you should do like 0 plus 4q by 2. Here also charge on q is no charge, so it will be 0 plus minus 2q by 2. So whenever the question comes like this, two bodies are brought in contact, the charges will be reduced. So coming back to this question, 4q plus minus 2q, so q will be charged on each. So q will be the two charges, and they are separated by some distance. We don't know what is the distance, but we know the force which is exerted. So let the so in this case the force will be equal to 1 by 4 pi epsilon 0 q into q by r square. In the other case, the given force, capital force, was equal to 1 by 4 pi epsilon 0 4q times minus 2q by r square, when you write in the equation form. So let us compare the two equations. So this can be written as 4 into minus 2 minus 8 1 by 4 pi epsilon 0 q squared by r squared, and our new force is 1 by 4 pi epsilon 0 q squared by r squared. So when you write it, the old force was equal to, the given force was equal to minus 8. See, minus means it is a attractive force, so ignore the negative sign. 8 times the new force. So what is the new force? New force is equal to 1 by 8 times the old force. So what you have to do is, when the two charges are given an r, and if they are brought in contact, the charges will be reduced. You find the sum of the charges and divide it by 2. So this q will be on each body, and write the equation with the new charges and write the equation with the given charges and compare the two equations. Then you can find out that the new force is actually 1 by 8 times of the given force. Thank you.